Hi, and welcome to our 2.1 notes on inequalities. The first thing we're going to talk about is how to graph on a number line. So we have four symbols here. This first one we can read as x is greater than -2. So to graph this, we're going to start with a number line. So we should always have our number in the middle. And then we're going to pick a number to the right. So we can kind of think about how we're approaching 0 on the right. On this side, it's going to get more negative. Terrible looking 3. There we go. So in order to graph this, we want to graph all the numbers that are to the right of -2, but not including -2. And the way that we do this is by using an open circle. And then we just draw an arrow that goes to the right. Okay, so for all of these, we're going to start with -2 in the middle of our graph. We're going to have the same number line for all of these. So we usually just graph at least a number to the right and a number to the left. You don't need to do the whole number line because it is infinite, so you'd be there a while if you want to do all of them. So just enough to show which direction your number line is going. Make sure it is going from less negative or more negative on the left to less negative on the right towards your positive numbers. So our next symbol here is this one we would read as x is less than or equal to -2. Okay, so in order to graph this one, we're going to start at -2 again, but this one we are including -2 because that's the or equal to -2, and then the less than. So less than is the arrow, everything to the left of -2. The closed circle is the equal to. Okay. Our next one here is x is less than -2. So similar to our last one, except this one's going to be an open circle because -2 is not included. So less than -2, not including -2. And finally, x is greater than or equal to. I cannot talk at the same time. Hang on. All right, greater than or equal to -2. And that is going to be a closed circle because we are including -2, and this is greater than, so it's to the right. Okay. Now to solve an inequality, we have to remember one special rule. Most of it is going to be just like solving a regular equation. But when we multiply or divide by a negative number, you must reverse the inequality symbol, right? So that means if it's greater than, it goes to less than. If it's less than, it goes to greater than, okay? So just reverse the direction of the inequality symbol, but only if you multiply or divide by a negative number. So let's see a couple of examples to illustrate that. Okay, here's our first example. So we have 6x minus 8 is less than or equal to 3x plus 4. So our first step is to try to get all of our variables on one side. So I would do that by subtracting 3x on both sides. Those are going to cancel out. We get 3x minus 8 is less than or equal to 4. And then we can add 8 to both sides. We get 3x is less than or equal to 12. Divide by 3. Now I'm dividing by a positive number, so we're going to get x is less than or equal to 4. So I did not change the symbol because we divided by a positive 3. So here's my number line. We're going to graph this using a closed circle because we are including that 4. The or equal to includes that 4, and numbers that are less than that. And you can always check, right? We can say 3 is less than or equal to 4. That works, right? But 5 is less than or equal to 4. That doesn't work, right? So that's not going to be included. 3 is included, so it's on that part we're shading. Okay, so our next one here, I'm going to try to get the x's on the left. I think it's easier to read your inequality once you've done that. So I'm going to move this 13 over to the other side. So we're going to have negative 3x is less than or equal to 2x minus 13. Okay, and then I'm going to subtract 2x. And the reason why I've done this is to illustrate that rule. So we have negative 5x is less than or equal to negative 13. Okay, so now we have to divide by negative 5 on both sides. So when I do that, remember that symbol has to flip around. So we're going to get x is greater than or equal to 13 fifths. Okay, so x is greater than or equal to 13 fifths. So that's going to be the middle of my number line. Now we have to pick a number that's bigger and a number that's smaller. So 13 fifths is somewhere between 2 and 3. So I can use those as my, my points on either side. So 13 fifths is somewhere in there. Other than that, I don't really care. It's just somewhere between 2 and 3. We're going to graph by using a closed circle and graph to the right. Okay. So the next thing we're going to do here is check to see if negative 6 is a solution to the inequality. So remember, these have infinite solutions, right? If I look at my previous examples, anything greater than 13 fifths, there's an infinite number of possibilities that are going to make this inequality true. So we are just checking one possible solution, right? So we're just checking if negative 6 is one of the solutions that makes this true. So remember, when we're checking a solution, we're going to plug it in place of the x, or in this case, both x's. So I'm going to write 3 times negative 6 plus 7 is less than 2 times negative 6 plus 5. So let's simplify by doing our multiplication and our addition. Okay, so let's look at our result. I have negative 11 is less than negative 7. So when we're checking an equation, we're checking to make sure that it's the same number on both sides. But here we're not checking that they're the same because equals means same. Here I'm reading is negative 11 less than negative 7, right? So if I think of these on a number line, here's negative 7. Here's negative 11, right? Negative 11 is, in fact, less than negative 7. So that is true. So the answer to our question, right, is it a solution? Our answer is yes. So we just want to make sure it makes the inequality true. In this case, they don't have to be the same. In fact, if they were the same, this would not be a true statement because negative 7 would not be less than negative 7. It has to make it true using that inequality symbol. Okay, here we have a word problem as our last example for inequalities. So let's read through it. John is walking dogs at $5 per hour to earn money for a new game system. So far, he has saved $140. If the game system costs at least $300, how many more hours does he need to work? So I always like to figure out what our variable is. So in this case, rereading that last question where it says how many more hours does he need to work, we are going to make our variable represent the number of hours. So that's part one, define your variable. Then we're going to write our inequality. So we have $5 per hour, right? So we're going to think of that as our 5x because x, remember, means our hours. So $5 per hour would be $5 times the number of hours, x. He has $140 and he wants at least $300. Okay, so starting with that 5x, if we're making $5 per hour, we're going to add that to the money that we already have, and we want to make at least $300. So what does that mean? Can he make less than $300? No. Can he make more than $300? Yes. Can he make exactly $300? If I said at least, yes, he can make exactly $300. So that's how you can kind of think through the correct symbol that goes in your inequality. From there, we're just going to solve the same way we would solve an equation. So we're going to start by subtracting the 140. 300 minus 100 is 200, minus 40 is 160. And then divide by 5 on both sides. Again, this is a positive 5, so I'm not changing my symbol here. X is greater than or equal to 32. All right, so our last step here is to interpret. Now, when we interpret, we're going to interpret not just the number, but also that symbol, right? So in this case, he needs to work not just 32 hours, right? That would not be a good interpretation. He needs to work, we need a word, something like at least, right? Same as it was in the problem, at least 32 hours. Because that greater than or equal to, right, means at least. That's how we can convert it back into some sort of English sentence. So he needs to work at least another 32 hours. And that's how we interpret or answer in an inequality problem.